Alright, what's up guys? In this video, we're going to pick up some calculus here. We're going to be talking about using a Taylor series to evaluate a limit. So as to use a Taylor series here to evaluate the limit, we're given the limit as x goes to 0. We got cosine of 8x minus 1 minus 32x squared all over x squared. So the first thing you do with any limit is just try to plug the value in and see what happens. And obviously we know when we substitute this in, regardless of what we get in the numerator, we get 0 in the denominator, and that's ultimately a big problem because division by 0 is undefined. So a direct substitution will not work here. So the purpose of an activity like this is to give you some familiarity with using a Taylor series to evaluate a limit. Because if we go back to all of the strategies that we apply to try to evaluate limits, there's a bunch of different things that we can do. Factoring, multiplying by conjugate, all that stuff, and even L'Hopital's rule. So you have to ask yourself, well, could I apply L'Hopital's rule here to evaluate the limit? Perhaps. I mean, you would have to do it a number of times in order to get it down to the point where I can do a direct substitution. So can you do it using L'Hopital's rule? Probably. Would I want to do that? No, because it's going to take a little bit of work if we wanted to do that. So the purposes of using the Taylor series is to make the limit easier to deal with when all those other options are gone. So what we're going to try to find is the Taylor series for cosine of 8x, and since it's the limit as x goes to 0, we know that a is going to be equal to 0. So that's what we're looking for. So what is the Taylor series for f of x centered at 0? Or excuse me, for cosine of 8x centered at 0? Well, let's just think about the Taylor series of cosine of x where a is equal to 0. Okay. Hopefully you remember that the Taylor series for that, it's just going to be 1 minus x squared all over 2 factorial plus x to the 4th all over 4 factorial minus x to the 6th all over 6 factorial plus x to the 8th over 8 factorial, and so on, basically. So how does that help us? Well, help us because we can use the Taylor series for the function of cosine x centered at 0. We can use that to figure out what the Taylor series is for cosine of 8x. And so remember, this is how we represent it using the summation notation. It's going to be -1 all raised to the k multiplied by x raised to the 2k all divided by 2k factorial. And remember, that's for the absolute value of x is less than infinity. So given that we know that the Taylor series for cosine of x centered at 0 will give me this, we can easily tell what the Taylor series for cosine of 8x centered at 0 is going to be. So f of x is equal to cosine of 8x. And again, a here is 0. So we'll just use the Taylor series for that and modify it. So the Taylor series in our case for this is just going to end up being 1 minus 8x squared all over, remember 2 factorial is 2, so that'll just be 2 under there. And then it'll be plus 8x raised to the 4th power. 4 factorial is 24, so we'll just kind of simplify the factorials as we go along. And we can do one more. 8x to the 6th power. And 6 factorial is 720. So I have pretty much the first, I believe I have the first, maybe I'd say about 6 or 7 of the factorials memorized. They will start to get more difficult. The closer you start getting to 10, they're going to get a little bit more difficult to do in your head. So I think I've got mine, like I said, memorized up to 8, but after that, I just don't have them memorized. That's not necessarily relevant to this particular activity, but I just kind of want to throw that out there. And so you could essentially, like I said, just kind of keep going with this, of course. So what we can do is we can substitute in the Taylor series for this function at a is equal to 0 into the limit and try to simplify it and see if we can evaluate the limit that way. That's the whole purpose of this whole activity, although it may seem kind of stupid. That's pretty much the goal here. So we're just going to plug everything in. So it's going to be negative 1, or excuse me, not negative 1, it's going to be positive 1, excuse me, 1 minus, and we're just going to stick in our Taylor series, so it's going to be 1 minus 8x squared all over 2, and then that's going to be plus 8x to the 4th all over 24, minus 8x to the 6th power all over 720, and then remember on the top here, and I'll make the parentheses a little bigger. If we go back, we still got minus 1 minus 32x squared on top there. And we divide all of that by x squared. So if you've got it plugged in that way, then you're on the right track. So obviously there's some simplification and stuff like that we'll need to do, but I just wanted to show you how to get it set up. Okay, so that's just how you get it set up. Now we can start cleaning most of this work up and go from there. So you get the limit as x goes to 0, and we'll just have 1 minus 8x squared all over 2 plus 8x to the 4th all over 24. And then it's going to be minus 1 minus 32x squared. And we're going to divide all of that by x squared. Now we can simplify the top up here a little bit. We know that 1 minus 1 is obviously going to give us 0, and since we have an x squared down here, which is really what's causing the problem, what we can do is factor out an x squared from up in our numerator such that we can actually cancel out the x squared that's at the bottom, because really, like I mentioned, whatever we get in the numerator is essentially null and void if we're getting 0 in the denominator. So that's really what's causing the issue. Now, we don't care if we get 0 in the numerator, obviously, but it's the 0 in the denominator that's causing the issue. So we need to get rid of that. Otherwise, we're going to pretty much be in the same lane and not going anywhere. So what I'm going to do is I'm going to factor out an x squared. So you do have to be a little careful. So make sure when you're factoring out, you're being extremely careful. So it looks like I have negative 8 squared all over 2, because 2 factorial is 2. Then this would be plus. Now, I'll have 8 raised to the 4th power multiplied by x squared all over 24. And it would just basically, keep going like we talked about before. And this would be minus 32. And then that would be all over x squared. So what we've done now is got into a situation where we can get rid of the x squared and we can simplify. So now we got the limit as x goes to 0. And what are we going to get? Well, we'll get negative 64 all over 2. I know I'm going to do the simplification in a bit. I'm just trying to get you to see what happens. And then this will be plus. Now I need 8 raised to the 4th. I don't know what that is off the top of my head. It doesn't really matter because it's just going to go to 0, but I'm just going to do it anyway. So if I did it, I would get 4,096. So this would be 4,096 96. Again, it's not going to matter because once we stick in 0, I'm multiplying that by 0, which is just going to be 0 anyway. But just for the purposes of the video, I'm just going through and sticking it in there just so you can kind of see it. And that was all over 24 and so on. And it's just minus 32. That x squared at the bottom went away. Now notice that if we stuck in a 0, again, this would just give us 0 because 0 squared is 0. And if we kept going, again, we would just have our 8 raised to the 6th power multiplied by x raised to the 4th. And again, we would just stick in 0. So as we go along, we would continue to stick in zeros for x. So everything from that point on is just going to basically go to 0 if we keep substituting in the x is equal to 0. So in that case, we'll have the limit as x goes to 0. And what we'll end up with is negative 32 because negative 64 divided by 2 is negative 32. And then we do have a minus 32 over here. Negative 32 minus 32, that's negative 64, which is actually going to be our limit and our answer. So your final answer for this is negative 64. So again, I've done a few videos before, and they're on YouTube, of using a Taylor series to evaluate a limit. Is it something that you'll come across a whole lot, probably needing to do? Not really, but you know, it's always good to, you know, be able to deal with problems like this. All right, so that is your answer. So I'll post pictures of the solutions as well, but hopefully everything made sense. All right, so that is how you use a Taylor series to evaluate a limit. All right, I'll see y'all next time.